Hi everyone and welcome to this new video. So in this video I want to introduce you the world of bug bounty and to speak generally how does bug bounty work. So we're gonna ask, okay, what is bug bounty? What is the standard process when you find a bug and you want to apply it in a bug bounty program? We're gonna read an example of a bug bounty program and we're gonna see how we can read some bug bounty reports. So I hope the video is clear, I hope you get something out of it. If you want to support my work here on YouTube, you can subscribe to my Patreon. And I've also released a couple of courses on Udemy. One course is on web application penetration testing. That is the testing of web security, of the security of web applications, and the other is on Linux privilege escalation. So go and check out those courses, link in the description. So let's get started. What is bug bounty? Now, a bug bounty is a program offered by companies that rewards individuals for finding and reporting security issues through POCs. And these security issues are found in the software system or platforms that are developed by these companies. So basically, when you have a system, a digital system, and you want to show its security, you want to make sure that this system is secure, the question is, how do you prove security, right? This is one of the questions that I take in my course. I ask, okay, what is security? How we can prove that a system is secure? And the truth is that we cannot prove it directly. So the way we do it is through falsifiability. That is, we say, okay, if no one finds vulnerabilities, if no one finds ways to use my software, my systems, and my platform in a malicious way in order to obtain something, confidential data, access to computation, access to resources and stuff like that, if I let everyone try it out with their techniques, with their knowledge, and no one finds a vulnerability, then I can consider my system secure. And that is that by finding vulnerabilities in this process of finding vulnerabilities and issues and then fixing them, I make my system more secure. Now, to do this, you can either have a like a vertical testing, like a testing that is specific for one application, and that is typically a penetration test. So the company hires an external company, like a consulting company, to perform a penetration test over a set of applications. And after the test is done, you get a penetration testing report with all the vulnerabilities and the issues that were found during testing. Now, to do this, first of all, these tests are typically paid well, so there is money going on, of course, and you pay the consulting company for their time. You don't pay them for their output. This means that you can pay a consulting company for their time, and if they get you no vulnerability, you still have to pay them, of course. Now, in bug bounty is different, because in bug bounty, you pay single individuals, but only after they find vulnerabilities. So that is the idea of bug bounty. It is very competitive in terms of individuals because you have to compete with a lot of different people, and not only you have to find the vulnerability, but you have to be the first one to report it, to tell the client, the company, to create a report out of it and obtain the bounty. You have to be the first one, and the issue has to be in scope, has to be impactful. It's like, and you're competing with a lot of different people. So sometimes companies, what they do is they do both penetration testing and they also have bug bounty programs. So a bug bounty is especially useful when you have large companies or companies that have a lot of digital assets throughout the internet, for example. And so they have a bug bounty program so that if someone finds a vulnerability in this program, then they can use the bug bounty to report it and obtain a bounty. So, of course, in this context, you have to connect the individual people, the individual tester, the individual bug bounty hunters with the companies themselves. And so, as a way to connect them and make a profit out of it, bug bounty platforms have emerged. And these are, for example, this is a list of the bug bounty platforms like HackerOne, Bugcrowd, CNAC, Integrity, YesWeHack. So these are just a bunch of them. Basically, they exist as a way so that they offer a structured, secure, and efficient way of submitting security reports and obtaining a bounty. So that's the idea. Now, some large companies they also run independent bug bounty programs like Google, Meta, Microsoft, Apple. They have their own programs because they are large enough. They have the staff to support it, they have the resources, and things of the sort. And finally, there are other programs which are actually private, meaning that to enter into those programs, you must earn a reputation, you must be known in the community. And how do you get reputation? How do you become known? Well, you just have to find vulnerabilities and you have to explain them well. So that's the idea. Now in this video we will see YesWeHack and HackerOne in terms of platform. Now disclaimer, I'm not an expert in bug bounty because I never invested the time in it. I work as a penetration tester, I do consulting, and I also train. In this month specifically, I'm focusing a lot of time on the creation on teaching and training material, which takes a lot of time. In the following months, however, I do want to spend a little bit more on bug bounty, also to create teaching material to help you get started in it and to analyze the report that already exists. And we will see this at the end of the video. So basically, this is what bug bounty is. Now, what is the standard bug bounty process? Now, let's say that you have found a vulnerability. Now, a typical submission process looks as follows. And here I've tried to capture the most important thing that I think you should know. If you have a different opinion, feel free to write it in the comments. I would appreciate your feedback on it. So the first two steps have to do with double checking. Now you want to check two different things. First, you want to check that the vulnerability is truly impactful. That is, make sure the vulnerability exists and it has some impact on the business. So you want to make sure, double check to make sure the issue is real and impactful. This is extremely important as showing up with low impactful issue will just make you lose credibility, especially if these are non-issues. I mean, sometimes there are low issues which are not too important, but they still can mean something. Other times you will literally have spam of non-issue. Now that is just bad. You don't want to report non-issues because you will just lose credibility in the long run. So that's the first step. Make sure your vulnerability is real and impactful. And of course, each bug bounty program has its own rule for impact. Like they only care about certain vulnerabilities. For example, some bug bounty programs might say, look, we don't really care about HTML injection in this particular context. So if you find one, we don't care about those. So they are not considered impactful for the business. And of course, these kinds of reasoning, these kinds of decisions are made by the risk management team within the company. Like they consider all the possible impacts, all the possible consequences, and they just think, okay, look, this is not really that useful to us. So that's the first step. The second step is make sure the vulnerability is in scope, because each bug bounty has its own scope, and the scope defines what are the set of assets that are included in the program. If you find a vulnerability in one of these assets, then you get a bounty, otherwise not. And also the vulnerability themselves, the categories of vulnerabilities, the type of vulnerabilities, some of them can be in scope, some of them can be out of scope. Like as I was saying, maybe you have self cross-site scripting, like self stored cross-site scripting. Maybe this is not in scope because they're like, look, we don't care about this because you have to put malicious payload in a way that it will not affect other victim, other users in the system. So in that case, we will not consider in scope. So before even bothering to write a POC, a proof of concept, make sure that the vulnerability is found within the scope of the program. If the vulnerability is outside, you cannot use the program to submit it, and therefore you can even waste your time, but it's going to be time wasted. You're not going to get a bounty out of it. There are edge cases where you find an actual true impactful vulnerability. It is not in the scope. In that case, it is better to write to the security team to make sure, like, look, technically this is not in the scope, however, it's important. What can we do about it? It's better to contact the security team, and then you have some kind of special rule based on the situation. Now, after you have established that the vulnerability is real, that it is impactful, and it is found in the scope, you want to write the report for it, the POC. Now, the POC must detail a bunch of different things. So here it must detail where the vulnerability is found, how to exploit it, and what is the impact of exploitation. That is, what is the damage that the business will have to pay if they do not fix the vulnerability, the issue. Now, when you write POCs, you want to make sure that they are simple and reproducible, which means that you can add HTTP requests and responses, screenshot, code snippets, anything that will help your report to be clear and simple. As simple as possible. Of course, certain issues are inherently complex to understand, and so in those cases you cannot help but have a complex report. But in all situations in which you can simplify the what you're doing, basically you want to simplify that because it's gonna make it better for the team on the other end to read it. Now, on my web application penetration course, I put a lot of emphasis on the writing of POCs, and for every issue that we find, we also write a small POC detailing where it is found, the vulnerability, how to exploit it, and what is the impact. So to help to ease out all the effort that goes into the fixing activity, basically. So if you're interested in that, go and check it out and let me know what you think, like positive or negative feedback. I'm curious about it. Now, after that, you want to submit the report. So you want to put the report into the platform, and this, of course, depends on the specific platform. You have to fill out a bunch of different information, but in general, this step is not too hard. And then at this point, you have to wait for triaging to happen. So the company will review your finding based on various factors. Is it possible to reproduce the vulnerability? Is the vulnerability impactful when exploited? Is the vulnerability in scope? And this step, the step of validation of the report, can be an interactive step. You might interact with the team. They might be saying, I'm not able to reproduce this setup on my system. What is your configuration? So there might be an exchange of that type. And then at the end of the day, they will give you a reward, but only if you are the first one. If this also depends on the program, but most programs, they are like only the first report gets the bounty and the others are marked as duplicates. So that's really a sad situation to be in, to be honest. You find a cool vulnerability, but it's a duplicate, so you don't get the reward. But it happens when you do a lot of bug bounty. So basically, that is the idea. You want to wait for this. This step is interactive, and at the end of the day, you will get a bounty. Of course, as you can see, this process is a very human-driven process, which means that depending on the company, depending on the tester, you will have different kinds of interaction on the different ends of the communication. Sometimes the interaction is smooth, sometimes it has problem on the side of the tester, other times on the side of the company. So you get really a lot of different situations, and on this sense, it's just as complex as human interaction go. So that's the end. The only thing I have to say is make sure that what you write is clear and simple. This is really important if you don't want to lose credibility. Like if you want to do bug bounty in a serious way, you want to build a reputation and credibility. And to build reputation and credibility, you want to focus on the quality of your writing, on the quality of your proof of concept. This means no unnecessary words, no complexity for the sake of complexity, simple words, simple phrases, simple artifacts of exploitation, and make sure they are reproducible. Try to capture in as much detail as possible the environment you're testing on and what are the requirements for the exploit to work, because these are key. They are really important, and it is basically what will help the team on the company side to review your finding and fix it. And also don't forget that on their side, they're receiving probably a lot of different submissions. So make sure yours is of high quality. Now, at this point, let's read an example of a bug bounty program. And I want to read the bug bounty program of Infomaniac. Why Infomaniac? Because this year, Infomaniac is sponsoring my VPS, so Virtual Private Server. This is the server where I will host the forum for the support for my courses. So students who have purchased my courses will have a forum as a support platform, and this is hosted on an Infomaniac VPS. So Infomaniac is a Switzerland web hosting company, basically. So they offer services that have to do with web hosting, with cloud, with, like, for example, virtual private servers. and they have a bug bounty program. So this is what I want to analyze. Let's read the Infomaniac bug bounty program in here. So this is in the platform Yes We Hack. So let's read it together. So here is the title. So here we have the different kind of bounties depending on the low, medium, high, on the impact of the vulnerability. So low, medium, high, we have of course increasing level of bounties. The max reward has been 15k, sorry, not 50, 15k. And the average reward has been 728. So we have 37 URLs in scope, and we have supported languages, English and French. Now here there's this like introduction to the thing. We don't really care too much. Now what they do, for example, is when they host a new service, when they introduce a new service, they also develop a little bit of challenges around it. So for example, we have these challenges like Node.js hosting challenges, where you have this service, Node.js hosting, and if you find a vulnerability in this, and you have like, for example, 33 days, and if you find a vulnerability in this one, you will get a reward, basically. You will get a reward. So for example, we are thrilled to announce Managed Kubernetes Service. So like, you know, as they come up with services, they offer these new challenges. Of course, each program has its own dynamics. So there's no like blueprint. I mean, there's some things that are structured over different programs, but then each program is unique in its own way. For example, in this program, what they are looking for is this kind of vulnerabilities. So classical, horizontal, and vertical privilege escalation, so broken access control, SQL injection, and server-side request forgery for the injection attacks, so typical injection attacks. And then we have leaking of personal data, so customer data. We have network misconfiguration, insufficiently protected credentials, and server misconfiguration. So different forms of misconfiguration, and then leaking of personal data, because of course they deal a lot with personal data. And you know, there is here in Europe we have some regulation, although Switzerland is not in Europe, so I'm not sure how they relate to GDPR and things of the sort, but that's not the point of this video. The point of this video is to analyze a bug bounty program. So here we have some program rules, basically. So they are saying, okay, no denial of service, no testing that could cause degradation of or interruption of services. And for example, this thing also happens when you test, when you do a penetration test and you test in production. Like sometimes it happened to me that I did some tests in production and the client tells you like, look, this service is actually being executed in production. So if you test out, if you send some payload that could cause interruption of service because the server crashes, don't do that, because we're going to affect the availability of our users, and we don't want that. In this case, they're saying the same thing, because at the end of the day, these services are actually in production. So we are testing the production environments. Then they say, do not use automated scanners or tools in general that generate large amount of network traffic. For example, they don't want us to launch a big GoBuster, like GoBuster with a lot of words just to find out the name of a directory. They are not really interested in that, because at the end of the day, they want personal data. Like what they want is something that typically these kind of scanners are not really good at finding. If you have a custom scanner, be careful on the amount of traffic that this thing generates. I mean, these 2 points, after all, these 3 points, they're all connected basically, because they're like, these environments are in production, so be careful on how you approach testing. Okay, here they say no vulnerability disclosure, full, partial, or otherwise is allowed. This means that if you find a vulnerability, you cannot disclose it. So even after the triaging process, even after they accept or reject your report, you cannot disclose any information on the vulnerability. Other times, instead, you have a full disclosure. And when you're learning about bug bounty, you actually want to use the reports of other hunters to get started, to understand what are the sort of vulnerabilities that maybe a program has, so you get a rough idea of what to look for. And so like in this case, they are not giving you this information. Then they're like, do not copy any files from our application server and disclose them, of course, and do not modify, leak, or destroy user data. clearly. So here they talk about rewards, they talk about this stuff. They talk about specific testing conditions. So no denial of service. They also give the security email if you want to contact them for like doubts that you don't know. They use an OpenStack platform and they're like, if you find a vulnerability in here, this is out of scope. So we're not interested in that. Also here they are saying, for example, vulnerabilities on ticketing service, on page editor and site creator. In this section, they are saying that certain elements of the website is vulnerable to XSS because it is vulnerable to HTML and JavaScript injection. Now, they actually allow this. It is part of their business logic. And so this is a risk that they accept to have, basically. And so this means that they will not accept reports related to vulnerabilities in these specific services. For example, ticketing service editor or another ticketing page feature, basically, by an administrator, technical sales users that are targeting their own website users. So not of another client, of course. So what they're saying is that sometimes you think you found a vulnerability, but not really. So read careful about the program of a bug bounty program before you actually do some in-depth testing on that, because you might think you found something, but actually you did not. And for example, the same things happen in HTML injection. They're like, look, we allow HTML to inject the emails. This is not something that interests us. And they do not verify user emails because they want to provide a free and seamless user experience. So basically, the idea is that they are not verifying user emails because of a business logic decision, of a user experience decision. This is totally normal. Is there a security risk? There is. However, they just clearly state that they're not really interested in that kind of vulnerabilities. Also here we have also some scope for artificial intelligence methods like models, so like specific to AI. For example, if you can influence a model to impact the experience of other users, to access other users' data, or to extract the prompts and internal working for that particular model, that is how it was prompted, how it was programmed to act. But they are not really interested in like hallucination attacks, pretending falsely confidential data. That is, the model generates something that looks like confidential data, but it's not really confidential data. So it's an hallucination, how they call it. And so here, for example, we say, okay, here we start with the scope. So, for example, here we say we provide site creator instances for hunters to test. So here you get a website, and here you can test out, for example, this, which was created with site creator, and you can test this out. Or if you go down, so if you go down here, you have the actual scope of the program. So everything in K-Suite, all subdomains in K-Suite, which is the main application, basically. Like if you go here, you find the main application where you can log in, you can create your account and things of the sort. And so here you get all the services that are in scope. For example, API, login, manager, shop, all subdomains of Kchat, calendar, contacts, e-tickets, mail, Swiss backup, VOD, player radio, welcome. I think this is probably the like is it the landing page or something? No, we still need to like sign up. So this is still authenticated. So this is maybe the introduction to the service, how you authenticate to that. Basically, all of these are in scope. So if you find a vulnerability in one of these platforms, you can report it in the bug bounty program. And also look at this here, you find, for example, the code for the desktop K-Drive application, this one, which is a client syncing application with K-Drive, and it is written in C++. So if you find a vulnerability in there, once again, it is part of the scope. And here they have assets out of scope, like API.pub1.infomaniac.cloud, for example. This is not in scope. The newsletter is not in scope, and other things like this. Here is the qualifying vulnerabilities, SQL injection, cross-site scripting, remote code execution. Like many of these, by the way, I've talked about in my web application validation testing course. And these are non-qualifying vulnerabilities. So, for example, HTML injection in emails. For example, we have known CVs without working POC. So you get a vulnerable component, however, you cannot really validate the POC. Self XSS or XSS on page editor. So in this kind of some cross-site scripting are actually out of scope. And there are some unexploitable vulnerabilities, for example, expired certificates, other low severity cross-site request forgery, the lack, for example, CVS injection, lack of rate limiting brute forcing or CAPTCHA issues. This is another one. User enumeration, password requirements, policies. So like a lot of issues that sometimes you find in penetration testing reports, they actually do not care because they have decided with their risk management team, look, we don't really care about this, whatever, like we don't accept those kind of things. Now, since many of these websites actually require you to log in, you can create an account specifically for testing using the yeswehack.ninja domain, the aliases basically. And if you like, you can either test out the products for free, or you can subscribe at a reasonable price. So basically, you can get the minimum tier, and probably the infrastructure is the same, so you get access to the same service, and so it is. You can test out like that. And so this is an example of a bug bounty program, which I hope was interesting to read together. Maybe in the future I can bring some more example on like how you would test specific APIs for specific test kind of activities. Now, of course, bug bounty is a very competitive activity, so you not only need to find the vulnerability, you need to be the first one to find the vulnerability. However, I think there is a lot to be said on the teaching aspect, on the teaching methodology on how to approach bug bounty. And if you want to learn how to do bug bounty, what I suggest is start from reports. Starts from disclose report that maybe were assigned a bounty, so that were successful reports. Start from that. Now on this end, we can go to HackerOne. HackerOne, just another platform to read the some reports. And basically here, what you can do, here I'm gonna disable my webcam, but what you can do is you can sort out here by, for example, you can say filter. Here you can say severity, medium, high, or critical. So things that matter a little bit. You can say resolved. You say apply. And here you get a list of, for example, Shopify. And here we have this staff with restricted permission could access customer data after company removal. So this is a generic improper access control. This is like a medium because maybe the setup was a little bit difficult to do. This was, for example, let's say this Basecamp mutation-based store XSS on Trix editor version latest. And this was disclosed 2 months ago. So you click on here, you get the information on the participants reported by the company that it was reported to, the date, the original date, and also you can see the ether, the timeline basically. So this thing was originally reported on November 4, 2024, and at the end of the day, it was disclosed on a few months ago, 2025. So of course, a lot of things happen, and you can see how things evolve over time. So in this case, what we have is we have this Trix editor here. We have this application, and this is a rich text editor for everyday writing. Basically, if I got it right, this one is Electron application. So it means that it can run on desktop and also on a browser, probably. And so basically what it means is that they have this payload, which can be used to trigger an XSS. Here you put the payload here on error. And the problem with having an XSS on an Electron application is that this can actually be used to perform a code execution. And so in this case, here you have the POC, and here we have the POC to pop a calculator. So to abuse the cross-site scripting in order to trigger the calculator, so to trigger code execution. And so by reading this kind of reports, you also get a glimpse on what kind of payloads work, why they work, what was the problem. And I think in general, it really can enrich your understanding of how to write reports. As you can see here, there's a back and forth because they were not able to reproduce initially. They had some trouble. And then after a while, they were able to reproduce the issue. And then they fixed the issue. They understood what was the problem. And by reading these reports, you get a glimpse on how things are done before even your first bounty. And of course, what I suggest also is to understand what kind of vulnerability you want to find. You want a mutation base, store XSS, or a race condition, a privilege persistent, like user limit bypass. You have different kind of vulnerabilities depending on what you're looking for, basically. And here you can, I think you can filter also for vulnerability type using the CWE here. Let me remove once again my webcam, vulnerability type here, and you get a list of vulnerabilities. And so I really suggest you to start reading some reports. I think I'm gonna create some content on the matter in the future. So if you're interested in that, let me know and I'll see what I can do on the matter. I hope this video was useful. I hope you got something out of it. If you want to support my work, there is a Patreon, and I'm planning to have a forum for student support and for Patreon support. So I'm gonna talk about that more in the future. So this is for this video. Thank you very much, and to the next video.